Hello and welcome. In the last video, we created business logic using classes. Now it's time to move one level deeper, into table methods. Tables are not just containers for data. They are also the first line of defense for data quality. In this video, we'll see how to write custom table methods, override standard table methods, add validations, auto-generate values, and fix things we conveniently ignored earlier. Let's begin. Let's start with custom table methods. For every table I create, I follow one simple practice. I always write a find method. Why? Because reading data should be clear, predictable, and reusable. For our leave requests table, the primary key is leave request ID. So we create a method called find. The method takes leave request ID as input and returns the matching record. When someone reads this code later, it's immediately clear, this method finds a record by its primary identifier. Now let's say we want to find all leave requests for an employee. Instead of overloading the same method, we make the name explicit. So we create a method called findEmployeeID. Just by reading the name, we know exactly what it does. No guessing. No comments required. That's the power of good naming. Now let's move to overriding standard table methods. First is validateField. This method is called whenever a field value changes. Perfect place for validations. In our case, we want to validate toDate. If someone enters a toDate that is before the from date, that's not leave, that's time travel. So inside validateField, when the field is toDate, we check whether toDate is greater than from date. If not, we throw an error message and stop the user. Simple, clean, and enforced everywhere, not just on one form. Next method is initValue. This method is called every time a new record is initialized. And here's something we missed earlier. The leave request ID should not be entered by the user. The system should generate it. So we fix that now. We create a method called findLastRequest, which fetches the last created leave request. Then we create another method called getNextReqID, which takes the last ID and increments it. Inside initValue, we call getNextReqID and assign the value to leave request ID. Now every new record automatically gets an ID. No user input. Now let's override another important method, insert. Insert is called just before the record is saved to the database. This is the perfect place to calculate derived values. Earlier, our number of leave days was always 0. Not ideal. So before calling super, in insert, we calculate the difference between toDate and fromDate. And store it in leave days. Now the value is always correct. And it's calculated exactly once. Now let's test everything. We build the solution. Reload the application. Open leave requests. First, try entering a toDate before fromDate. The error message appears. Validation works. Now look at the previous record. Leave request ID and leave days are empty, because logic didn't exist then. Now create a new leave request. This time, leave request ID is filled automatically. Leave days is calculated correctly. And suddenly, the table is doing real work. So in this video, we enhanced our table with real behavior. We added find methods for clean data access. We enforced validation at the table level. We generated system-controlled values. And we calculated derived data automatically. This is why table methods are so powerful. They protect your data, no matter where it comes from. In the next video, we'll continue strengthening our logic and see how tables and classes work together. Thanks for watching. And remember, if bad data enters the table, everything above it is already in trouble.